This is the SPE Live Podcast, powered by the Society of Petroleum Engineers. You're listening to SPE Live. Interoperability is a key factor to better drilling automation. The audio from this episode was previously recorded on January 11th, 2023. And now your moderator, Deep Joshi.
Good morning, everyone. Welcome to the SPE Live on interoperability as a key factor to better drilling automation. My name is Deep Joshi. I'm a data scientist at Quantum Energy Partners. Today's SPE Live will last 30 minutes. Drilling operations involve many different service providers, each addressing specific facets of the well construction process. In practice, the drilling organization, including the support from onshore operation centers, addresses the coordination of various tasks executed by multiple entities. Yet, the natural fragmentation of drilling operation into multiple services has slowed down the implementation of drilling automation solutions because computer systems from each individual party are traditionally not designed to exchange information with the other systems. The SPE Drilling System Automation Technical Section has therefore started an initiative to define standards for computer interoperability during the drilling process. This subcommittee, called D-WIS, which stands for Drilling and Wells Interoperability Standards. It's now my pleasure to introduce our guest. Eric Cayeux is a chief scientist for Drilling and Well Modeling Group at the Norwegian Research Center. He works with multidisciplinary solutions for well planning, real-time diagnostic of drilling operations, drilling automation, mathematical modeling of drilling processes and sensors. Cayeux holds an MS degree in civil engineering from Lyon, France, an MS degree in software engineering from the University of Nice, France, and a PhD in petroleum engineering from the University of Stavanger, Norway. Cayeux received the SPE International Drilling Engineering Award in 2022. Eric, welcome to the SPE Live.
Thank you very much for this nice introduction.
So, Eric, what are some of the common challenges associated with drilling operations?
Well, there are actually many different challenges associated with the automation of the drilling operations. And one of the most important background problem is the fact that drilling operation is involving many different companies, and each of those companies is representing different disciplines. So the setup of the companies during the drilling operation changes as the well construction process evolves. So, for example, you don't have the same companies when you are drilling, when you are running the casing and cementing and so forth. So basically, we have a constellation of different companies which is changing, and this makes the drilling process automation quite complex because of the changes that you have around that. Now, each of those companies which are involved into the drilling process are not really used to exchange information. And the coordination of between the different companies is mostly done by the drilling organization itself. So it's more like human-centered. So the existing system which exists for exchanging information are often proprietary, and they have targeted with specific implementation. And because of that, it's quite difficult to scale every single automation applications across the industry, because you have the change of the different companies that you have in the different drilling operations. So we need also to recognize that the drilling contractor has a very central position in the drilling operation, since the driller is one who is operating the drilling machines. And it has, of course, the responsibility of the drilling operation in practice. The driller is using the drilling control system, and the drilling control system is mostly focused on the drilling machine and not really on the drilling process. So it's quite important when we are trying to automate the drilling process that we inform the driller as much as we can about the current situation, so that we help actually the driller understanding what is happening when we are running automation functions. And this is an important concept around human in the loop for automation. So we need to respect the notions of separation of concerns and make sure that the drilling contractor is the central piece of the puzzle for automation and the implementation, because they are in fine the one who are responsible for running the drilling machines. Yes.
So you mentioned drilling processes and drilling machines both. How is controlling a drilling process different than just controlling with drilling machines?
Yes. So if we look at the drilling control system which exists nowadays on modern rigs, they are focused on controlling the drilling machines and making sure that we will have a safe operation of the machines. So what does that mean? That means that actually embedded into the drilling control system, so we have some mechanisms for detecting faults and reacting to those faults. An example of this would be, for example, machine anti-collision. And you have also implementation of safe operating envelopes, like, for example, making sure that you will not exceed the amount of power which is available for driving each of those machines. But everything is focused on the machine. Now, the drilling process is very different because it englobes, of course, the drilling machine, but it also englobes everything which is downhole. And what is downhole, or the drilling system completely, is actually a very complex entity. It's really important to understand that actually a trace string and a wellbore is extremely slender. And because of this slenderness that we are talking, so we have very small diameters compared to the lengths. That's what this slenderness means. We have a lot of elasticity and compressibility of the system, both in terms of the string and the fluids. And that means that when we give a command on the machine, so there is very long reaction times. Now, the drillers, with experience, they get a gut feeling about these delays and limits that they need to work with. And it's only nowadays that actually we are capable of having a computer system which can integrate in real time this type of estimation of the limits and thresholds, so that you can avoid drilling incidents and optimize the drilling process. So the problem with these calculations, or the computations that needs to be done, is that they depend on many different sources of information. And these sources of information are spread amongst all those participants that I mentioned in the previous question. And therefore, there is a problem that the DCS, if it needs to implement automation, need to understand or to utilize the fact that we have a drilling process and not only the drilling machine. And at the same time, it is not necessarily having access to all the information which is necessary for calculating those limits and thresholds and optimization for the drilling procedures, for the operational procedures. So it's important that actually that this drilling control system can exploit information which is made available elsewhere. And that's why some of those drilling control systems are accepting actually advice from external agents. So that's a new offer which has been available for a few years now, that the drilling control system vendors started to provide the ability for external agents or algorithms or routines to configure their own functionality from external information. So with this being said, so it's this new type of drilling control system are now classified as automated drilling control system, or ADCS. And the advantage of this new functionality is that that more novice drillers can benefit of functionalities which assist them during the drilling process and render the process more safe and more efficient. Probably it doesn't compete with the best experienced drillers, but it's maybe an assistance for more novice or standard drillers.
What are some of the difficulties associated with external agents communicating with the DCS?
Yeah, so that's a big problem, because actually every ADCS vendor has implemented its own way for being interfaced. So that make very difficult actually to external agents or provider of external agents to interface with the different ADCS. You need to reconnect for each of those different solutions for interfacing. And then when you go to the rig site, so every rig is different. Even if you have a fleet of the same rigs, there are small nuances between each of those rigs. And you need to do a lot of work for adapting your external agent solution for each of those different ADCS vendors, rig configurations, and even during the operation. So the constellation of different actors may change, and then you need to reconfigure everything. So it's a lot of work. So much time is used in trying to adapt all these functionalities for the different contexts, and that slows down statistically the adoption of drilling automation across the industry, because that has a direct impact on the cost for implementing automation. If you think about each installation of an external agent at the rig site, you will need to go through a factory acceptance test, a site acceptance test, and a lot of many months of engineering ahead of that to provide a solution. So there is therefore this idea that was born about 4 or 5 years ago, that actually there was an industry standard for interoperability at the rig site. Then we could have a kind of middleware which is placed between those external agents and the ADCS, which would render this communication as seamless as possible, and therefore reduce the cost for installation of automation functions. Now, what is important is when we build this middleware for the interoperability, it should not be based on a kind of common denominator for the functionalities which exist on all ADCS, because then that would be very limited. On the contrary, it needs to be very flexible and to accommodate for many solutions of which doesn't exist yet. It needs to think about the future. And this is what one of the challenges that we have actually when we are trying to define an interoperability layer, is to make sure that we can both accommodate with the present, but also be reliable for the future as well. And the reason is that if we don't account for this future evolution, the standard will be always out of date, and there is a risk then it will not be adopted because it will be delayed compared to the current functionalities which are made available in the industry. So the last thing is that an interoperability architecture should be able to accommodate for the multitude of different service providers that exist out there, and be able to sort out orchestration so that if you have multiple external agents, you can sort out which functions needs to be prioritized and how conflicts are resolved. Yes.
So you mentioned the interoperability between DCS and external agents. What are some of the methods that are being investigated for achieving this interoperability objective?
Yeah, so that's what the work we have been doing in the D-WIS organization is basically to use actively this notion of capability description. So if you think about each ADCS, it can describe in a computer readable format its capabilities. And then external agents can read those capabilities and adapt to the existing capabilities. So if we achieve that means that actually that you don't need to recode or to recertify your external agents all the time, because then you have something which is very flexible. So the standard, the standard is about being able to describe these capabilities, being able to provide management of conflict resolutions and prioritization. And of course, we also try to provide example that can make of those capability description, so that actually the life of implementers of external agents is as simple as possible. Now, need to realize also that most ADCS, and that goes back to the responsibility of the drilling contractor about for the operation. They have in fine the people who has the responsibility of the safety of the drilling operation. Therefore, the functionalities which exist at the level of the ADCS are usually hard-coded and tested very, very seriously. And the only thing that they allow are to be configured for some parameters by those external agents. And this is part of those very standard capabilities which can exist. Now, some more advanced ADCS can provide even better functionalities, like, for example, the possibility to schedule new tasks on the fly. And that is quite nice, because that means that actually that you can have relatively flexible ways of implementing automation with this type of flexibility. But even if we have that, so if new tasks are pushed on the ADCS system, so we need to make sure that the end user, the driller, is capable of understanding what is happening. And for that, we need to push those tasks with a lot of context, so that actually the driller can both accept and or reject the new tasks which are being pushed on the automation system. So the design of the architecture that we are putting together is really centered around this principle of separation of concern. So we have a hierarchical control, and we need actually to make sure that there are each of the layers in this hierarchical control are not interfering with each other, so that actually we don't create jamming situations between the different automation functions with their respective layers in the hierarchical control. In addition to that, so we have a kind of cement for all these functionalities, which is exchange of signals at the very site, which is based on a semantic description of each of the signals, which is computer interpretable, and therefore making sure that any parties can read and understand the signals which are made available, and therefore you don't need to have a manual work for connecting to every signals which are made available at the rig site all the time. And that facilitates a lot, actually, the implementation for drilling automation.
How is this D-WIS's work on interoperability organized?
Yeah, so it's a cross-industry cooperation, which is a subcommittee of SPE DSATs, Drilling System Automation Technical Section. And it's a very nice setup. There are plenty of different companies who are participating to the effort. It's really active. Many meetings every week, and a lot of participants who are really spending a lot of time helping getting this interoperability working together. So one of the things we discovered at the start was actually every of us working in this D-WIS organization or D-WIS subcommittee had different backgrounds, and actually we were not it was not easy to communicate with each other because maybe some words has different meanings depending on the backgrounds that we had. So we spent some time to define a common glossary of concepts and put that together so that actually when we talk about the concept, then everybody can agree that it is referring to this definition. Now, all these definitions and facets are put together into some web pages that you can find on a website which is called D-WIS.org. So anyone who is listening to this session is encouraged to visit this site. You will find a lot of information there. Otherwise, the subcommittee is organized with 4 different work streams. We're working on different aspects of the problem of interoperability. So one work stream is called Drilling Process Protection and address the problems of how to interoperate with fault detection, isolation, recovery functionalities, with safe operating envelope functionalities, with feedback controllers, with standard procedures. We have also another work stream working on the ADCS interface, which is proposing an interface to the automated drilling control system technology layer of the drilling rig. And we have a third work stream which is working on the reference architecture and which is especially working on the prioritization of different requests and the orchestration of the different advice. And we have a fourth work stream which is working on exchanging drilling data through a hub where the meaning of the signals is described using a method called semantic network, and which means that actually the computer systems can interpret the meaning of the information which is exchanged. So right now we are focusing on preparing some demonstrations on how all these pieces are working together. We start with the simplest one we could thought about, and that's how we can have ROP optimization system working with many different types of scenarios for the ADCS. And then we will go to more and more complex situations or scenarios, like, for example, a generic downlinking system to downhole tools, and then simpler and complex pump startup procedures, and so on and so forth. So, and I really encourage everyone who is interested in that topic to join. You can do that by visiting this website, d-wis.org, and you can register and say that you are interested, and you can, if you want to join. So the more people, the better it is for the community.
Eric, all the work you described from D-WIS sounds really fascinating. So is the goal for this work to replace existing standards at SWITSML or work alongside it?
No, it's really to work alongside. So SWITSML has its own purpose and it's very well developed. So we try to supplement the work from SWITSML. And we really focused on this interoperability with the drilling control system, or the ADCS, with the automated drilling control system. And that's really working alongside other standards. And when standards are already existing, so we use them. So, for example, OPC UA is one of the things that we are adopting for this, as it's a suitable way of exchanging information at the rig site.
What are some of the common roadblocks you've seen in implementing interoperability in the industry-wide?
Well, there are many roadblocks possible. The first thing is that if the standard is not adapted to the requirements of the end user, that will not be adopted. So that really need to think about practicality so that it is useful. The other thing is is that if the standard is always 1 year behind what the industry is doing, then it will not be adopted either. So we need to be really flexible. We need to have a standard, which means that when it is installed, you can stay with it for many years without having to enhance or to make a new revision of the standard. So the longer the time between revisions, the better it is for the standard to be a good standard.
Now we'll take a couple of questions from LinkedIn. The first question is, you mentioned the communication between drilling machine control system and external applications. Can you please explain more about this?
Yes. So basically, the ADCS or different ADCS may have different interfaces which are made available for external parties to communicate with them. And usually it's in terms of parameters for functions which exist inside the ADCS. Now, we put an additional layer in between, which contains this capability description, and which indicates, and this capability description indicates where these parameters are made available and how to access them. So the external application or the external agent can read these capabilities and utilize this capabilities description to find what it should send and how to send it actually to the ADCS. And there is a two-way communication. So the ADCS also can communicate some feedback about when the function is turned on, when it's turned off, when it's ready, and so on and so forth. And this also is described in the capability description. And the external agent can read this information and utilize that for the way it can communicate.
We'll take another question from LinkedIn. How risky is the new automation system compared to conventional drilling systems?
Yeah, that can be risky. Of course, it's but I would say that in many cases, actually, the drilling automation functionalities, instead of increasing the risk, are decreasing the risk. So they can help actually detect situations and react upon those situations very quickly, much faster than a driller. So I will take an example from detections of, for example, pack-off or overpulls or overtorques and facets. And so the automation system can really detect those things in just a fraction of a second or a few seconds, and act upon that. And we have seen in many cases actually that when this type of functionality are implemented at the rig site, they do trigger quite a lot, and most often actually much faster than what the driller could do. So they are really helpful, not necessarily increasing the risk, but assisting the driller. I think that's the key word. And when I've been working with development of such functionalities, and I've talked to the driller, I try to explain to them the point is not to replace them, but actually to assist them, and that was really important for them, and they really take that as an important fact that this is fundamentally an assistance for them.
Thanks a lot, Eric. Thanks for the discussion. And with that, conclude this SPE Live. Thank you.
Thanks for listening to the SPE Live podcast. For more content, visit the SPE Energy Stream, the industry's digital pulse, at streaming.spe.org. If you enjoyed today's show, don't forget to subscribe and review. Join us next time on the SPE Live podcast.